As we look at hyperbolas, we're going to notice that they have a different shape, conic shape, than what we've seen. It's sort of as if we have two parabolas facing away from each other. We do have some of the same characteristics in a hyperbola, that we have a focus and a vertex, which all are on the same line of symmetry. And we have the same values that we've seen before, an A, B, and a C. And looking at the standard form of the equations, we have looks very similar to our elliptical or our ellipse formula. We have x squared horizontal hyperbola. We have x squared over a squared minus y squared over b squared equals 1. So we'll notice that A and C on the horizontal hyperbola are on the same line. And then if we turn around and look at the vertical hyperbola, it looks like A is going to fall underneath my y squared. So my C and my A fall on the same vertical line of symmetry. So those are some characteristics that we can quickly ID. And then of course my focus is going to be c squared equals a squared plus b squared. So a little change in my focus formula. So as we look, we can look at this first example, and we have writing and graphing the equation of hyperbola. What is the standard form of the equation of the hyperbola with vertices of 0, 4, and 0, negative 4, and a foci of 0, negative 5, and 5? And if we go ahead and graph those two real quick before we make any assumptions or any comparing to the formulas. And so if I go ahead and graph my vertices occur at 0, 4 and 0, negative 4, and my foci occur at 0, 5, 0, negative 5. So somewhere about right here. Well, that should tell me that my hyperbola is going to be opening vertically something like that, because my focus is going to be on the inside of my hyperbola. So something like that. So we should know that that is going to be a vertical. That's going to be a vertical hyperbola. So my function is going to be y squared over a squared minus x squared over b squared is equal to 1. And we know then that A is going to be my vertices, and we know that A is going to be 4. So we're going to have 4 squared, and so we know that the value of C, my foci, is 5. We know the value of B, we don't know that value of B. And we know the value of A is going to be 4, so if I take my Pythagorean Theorem, C squared is equal to a squared plus b squared, I know that 5 squared is equal to 4 squared plus b squared, and all of that is going to equal, 25 equals 16 equals b squared. B is going to end up equaling 3. So when I go to correct my equation, I know that a squared was 4 squared, and I know that b squared is 3 squared. Therefore, my standard form of the equation is going to be y squared over 16 minus x squared over 9 equals 1. All right, as I continue this next example, it says to go ahead and sketch it. Check it with a calculator. Well, you guys can worry about that later, but we know that C is going to be equal to plus or minus 5. That's going to be my foci. Or in this case, it's going to be 0, 5, 0, negative 5. And then my vertices, we said, is going to be A is equal to plus or minus 4, or it's going to be 0, 4, 0, negative 4. And we have graphed those 2 points already on our graph. And the thing that we don't have is going to be our B. And our B is going to be equal to, not sure if it matters, but we know B is equal to 3. So if we use our asymptote formula, that will tell us where our asymptotes occur. And remember, our asymptotes are these points that our graph gets really close to but doesn't touch. These are going to be y equals plus or minus a, which is 4 over b, which is 3x, and then it is also going to be equal to plus or minus. So let's just go with something like this. 1 is going to be equal to plus, and 1 is going to be equal to minus 4/3 x. And if I think about that, this is going to be plus 0, so my y-intercept is going to be the origin, and I'm going to, for one of those equations, go, let's see here, up 4 over 3. So there's going to be one asymptote, and the other asymptote is going to be down 4 over 3. Look at something like that. And so then I know my functions, which I sort of put in here before, actually going to go a little bit more up the function there. So again, now I have graphed the function. You can see my equation follows up the asymptote, and there you go. There you have it. That is graphed. All right, so looking and analyze a hyperbola from its equation, and it wants to know what are my vertex, my foci, and the asymptotes of the hyperbola with the equation of this. It is 9x squared minus 4y squared equals 36. My standard form of the equation is the most important thing, though. We want to get it into the equals 1. And in order to get an equation equal to 1 here, I'm going to go ahead and divide by 36, because I know that 36 divided by 36 is going to give me a 1. So dividing everything else by 36, because what you do on one side of the equation you must do on the other, I end up with x squared over 4 minus y squared over 9, and that would be x squared over 2 squared minus y squared over 3 squared equals 1. So I know a or b is going to be equal to 1. So let's see. Since x squared is going to be my leading term, I know that, let's see, I have x squared over 4 minus, instead of rewriting that, let's just look at this. So a is going to be equal to 2, and b is going to be equal to 3. So I know then that I would have c squared equals 2 squared plus 3 squared, so c squared is equal to 13, or c is equal to the square root of 13. So I have established what my a, b, and my c values are, so I can go ahead and then just work them into my formulas, my vertices. Okay, so my vertices are going to be plus or minus a, so I know that a is going to be 2, so I'm going to have 2, 0, and negative 2, 0. My foci are going to be plus or minus c0, and then because it lies on the same vertical line as my vertices, so my c value is going to be plus the square root of 13, 0, and minus the square root of 13, 0. And I think 13 is approximately, okay, so again, the square root of 13 is approximately 3.6, and then my asymptotes are going to be y equals plus or minus b over ax, or y equals 3/2 x, or y equals negative 3/2 x. So what we can do is go ahead and create our coordinate plane, and we're going to, easy enough, let's go ahead and graph my asymptotes first, And that is going to be starting off the origin, going up 3 over 2, up 3 over 2, down 3 over 2, and then, so my asymptotes are going to connect through those 3 points, and doing the same thing over here. All right, so they're my asymptotes. And let's see, now I know then that my foci, my vertices were going to be 2 and -2 and 0. And then my foci were going to be the square root of 13, which turned out to be plus or minus 3.6 roughly, right? About 3.5. And then if I went ahead and graphed this, following up my asymptotes, going through my vertices, there we go, have something like that, have something like that, and there you go, there we have graphed that hyperbola.